So we were discussing this program in the last class, right? So in this program we were trying to find out whether a number is prime at all. How does it find out whether a number is prime at all? Is basic consideration is it will try to divide the what you call number by its previous numbers from the beginning, from 2 onwards, till the number which is half of it, For example, you know, and in between, if it is divisible by any number, then it is not a prime number. Okay, if it is divisible by any number, it is not a prime number. That it should test till half of that value. For example, here he has taken 14. Okay, so first I is initialized. We are trying to test whether 14 is a prime number. So first we are setting is prime to be true, which is a Boolean variable. Then the number itself we have written here as 14. Then we are taking here as initialization I equal to 2, because we have to test whether it is divisible by 2, and then the higher numbers till next what you call, you can say half the number of this. Okay, but however, if this number is divisible by any one of the number, then naturally it is not a what you call prime. So it should be set false, and then we should break it. It's sufficient that it should be divisible by one of the numbers which is below it. Okay, the prime number is 1. If it is what you call divisible by one of the numbers below it, then automatically it will turn to be a what you call, if it is divisible by any of the numbers, it is not a prime. If it is not divisible by any one of the numbers, then it is what you call prime. Okay, so if a number is divisible by any number which is below it, it cannot be a prime number. That is the consideration with which we are going. So I is equal to 2 is what we have taken. Then we are dividing that number, 14 by 2, that is 7. So here 2 is less than or equal to 7, so condition is satisfied. So hence we go inside 12 modulus 2, 14 modulus 2 will give us the value, remainder 0. So because it is divisible by 2, 14 is divisible by 2, because at that time we'll not have a remainder, we'll set it to false. So once it is set to false, then we break it, because it is divisible by one of the numbers, that is 2, and hence we'll go. Similarly, say you take here a value which is 14. Okay, so first we start with 2, right? 2 is less than or equal to 15 by 2. That is, again, this will convert it into an integer. 15 by 2 will become 7. 2 is less than 7, hence it will go inside. Once it goes inside 7, this is 15 divided by 2 will give us a remainder 1. So the condition here is not satisfied. So it will not enter the body of the if over here. Okay, it will not enter the body of the if over here, because of the reason that 15 modulus I, 15 modulus 2 will be equal to 1, and 1 is not equal to 0. So that means this condition is what you call not satisfied. Hence we will not enter this. Next, it will go for the next iteration of the for loop. So I plus plus will get, so then we'll get 3 divided by 15 by 3. That is 3 divided by 15 by 3 will give 3 divided by 3 less than 15 by 3 will give us 3 less than 5, which is true. And we'll go here 15, modulus 3 will become equal to 0, and that means this condition is satisfied. Hence we will enter it over here, and it will give false. And hence, because 15 is divisible by 3, it is not a prime number, and we come out of that. Now let us take a number which is, say, 17. Okay, so if we take the number to be 17 over here, first I is equal to 2. So what you call 2 less than or equal to 17 by 2. 17 by 2 converted into integer will be 8. 2 is less than 8, and hence we will go for the what you call condition over here. 17 modulus 2 will give us a number which is other than 0. So this is not satisfied, hence it will not enter over here. So still the prime will be true, and we go for the next iteration, that is I is equal to 3. So 3 less than or equal to 17 by 3. 17 by 3 is a value which is 5. So now 17 by 3 is a value which is 5 there. So 5 is we will see that the what you call 3 less than 5 is true, hence we will enter this. 17 modulus 3 will give us a value which is 2, and 2 is not equal to 0, condition is not satisfied, hence we come out, and again I is incremented to 4. Now 4 less than or equal to 17 by 4. 17 by 4 will give us the value 4 itself. 4 equal to 4 will satisfy it. Okay, 4 equal to 4 will satisfy it. Hence, we'll enter here 17 modulus 4 will give us a value 1. 1 is not equal to 0. Hence, again, we will not enter this body over here and come out, and I will become equal to 5. I will become equal to 5. So once I becomes equal to 5, 5 less than 17 by 5 will give us the condition is not satisfied over here now. Okay, condition is not satisfied here. Okay, so therefore we will not have a condition satisfaction, hence it will not enter, and then it will give that it will just come out of that thing and say that it's a prime number. Okay, it's a prime number because this is no more a satisfaction statement. Will come out of that, and we will, if is prime is now true, it will print prime, and otherwise it will print the not prime. So we have already executed this program, but still let us try to do it once more. Okay, so might be we can execute it once more by putting it into the Google JDoodle, as well as we will try to put the value equal to might be 17, and then see how it executes it. So might be we'll try to add some code to it and then see how it behaves. So each time I face this problem because it becomes slow. So I think I should clear my laptop. Okay. I'm here. So still it is working. The browser is so I'm pasting here the code. Okay, so what I'll try to do is I'll just print another system.out.println, and I'll try to print the value of the I also. Okay, till what of value of I it will take it. So where shall we print that? Might be within here, before checking the condition. I'll not print from there, I'll print from here, but I'll print the value of I. Copy within the body of the loop. Okay, so here what I'll do is now I. Okay, and plus I. So wantonly I'm just typing it like that. Okay, fine. So now I think we will see till what time the value of I will be for this value of 14. Say for 15, what is the value of I, last value of I? For 17, what is the last value of I? Okay, we can try to test that. For say 14, what will be the last value of I? So the value of I is 2. Okay, I think I might not have taken the print here properly. Might be I should have written here equal to, and then given a space, and then might be executed. Okay, so now it will give us that not prime, but it will give me proper value. So what I have is I equal to 2 over there, because it is getting divided by 2. So last I will be the I which it gets divided by 2. By the number with which it is, the last number with which it is getting divided. Otherwise, it might not be divided at all. If it is what you call not prime. If it is prime, it will get divided. If it is not prime, it will not get divided. Okay, so it's not prime. So the value which is 15 is getting divided by 3, this last number. Okay. Similarly, say if I write over here 17, so 17 we know is a prime number. Okay, so still will now I value and all that we'll get might be till 4 we'll get it, but then we'll get that it is prime. So if it is prime, it doesn't mean that it is divisible by any one of those numbers over here. Okay, it's testing for these 3 numbers whether it is divisible by that only. Okay, similarly we can give any number like that. So might be you can write 27, it's divisible by 3. Let us choose a number which is divisible by only something like 7. 49 should we write? 49 is divisible by only 7. Okay. 49 is divisible by 7, so it is testing with 2, 3, 4, 5, 6, and then 7. It is divisible by 7, and hence it is stopping. Okay, with not prime. Okay, so like that we can try to write. Says in the same way, can that number be 47? Yes, 47 I think should be a prime number. Let us check it. Okay, so it is just trying to check whether it is divisible by 2, 3, 4, 5, 6, right? And because it is not divisible by any one of those, it is giving us a prime number. So it's just checking whether it is divisible by any one of those numbers, or correspondingly, naturally, if it is not divisible by 2, 3, 4, it cannot be divisible by 2 into 3 into 4. Similarly, if it is not divisible by 5, it cannot be divisible by any number which is 2 divided by 2 divided by the multiplication of all these 4 numbers together, or any number which is below that. Okay, so that's how it is, and we can try to test it in this way. So let us go for the next program, right? Let us go for the next program and see what is there in store for us. Okay, then we have the comma separation, right? We can have the comma separated operators both in initialization as well as in incrementation. Okay, so there will be times when you will want to include more than one statement in initialization as well as iteration. Iteration means incrementation and decrementation. Both at this place as well as this place, we can have more than one statement, and that will be basically done by putting a comma over here or here. So what we are trying to do is we are taking one incrementation or iteration here, and another what you call the decrementation or iteration over here. Two iteration statements we are using. One within the for and one within the body of the for. Okay, one within the for and one within the body of the for. In place of this, we can put it comma b minus minus. You can remove it from here and put here b minus minus. Also, it should still give the same output. So we'll try both ways. What it is doing here is just trying to take the value of b as 4, and then we are putting it as, we are declaring a and b both as int. We are assigning 4 value to b, and then we are assigning 1 to a. 1 is less than b. Okay, we are going there inside and printing the value of a and b. So that means it will print 1 and 4, then incrementing the value of a. So then it is giving 2 less than 4, and again it will print 2 and 4 over here. It will check the value of b minus minus also. So first time when a is 1 less than b, it is going to check 1 less than b is true, hence it types this, okay, or prints this. Then a is incremented to 2, b is decremented to 3. So again 2 is less than 3, so it will print both the values of a and b. That will give us the value of a and b as 2 and 3. Next, a is incremented to 3 and b is decremented to 2, then the condition is not satisfied. So what it is going to print? First 1 and 4 for a and b, 2 and 3 for a and b. Then when it becomes 3 and 2 for a and b, this condition is not satisfied, hence it is not going to print it. So let us take this over here and do that, and then execute it. And further to that, we will try to see by shifting the place of b minus minus from this place to this place, whether it is getting giving us the same result or not. Okay, so let me execute this. Oh, there is an error because we have maybe an extra or less either one more brace or one less brace. I think it is one more brace, opening brace, so we should have one more closing brace. We should have one more closing brace. I think so. Let us see whether that is true. Okay. Let me execute it now. Yes. So it is giving 1, 4 for A and B, 2 and 3 for A and B. There might be this is not a proper so to say format. Might be we can write something like this. We can remove this ln. So to make it look better, we might try to do something like this. Okay. So then try to execute it. So now it gives first a equal to 1, b equal to 4, then a equal to 2, b equal to 3. When next a equals 3, b equal to 2, then a is not less than 2. So therefore it is stopping there itself. It is not, what you call giving the output. Now what we will do, so I have just removed ln over here, so it will not go to the next line when I go over here. And again, I am putting a space over here before b, so that the value which is printed for a does not get mixed up with b. Okay, so I have a space between the value 1 and b, 2 and b. Okay, that is why that space is given before b over here. Okay, and ln I have removed so that these two values will print in the same line. Next two values because we have put ln over here. For the next set of values, it is printing like that. So let me try to remove this b minus minus from here. Okay, I'll just write here, comma, b minus minus, and I'll delete that from here. It should still give me the same value. Yes, so it's still giving me the same value over here, right? Even though I have shifted the thing from here to here. So it's just the same. In place of writing it inside, I can write, two different values over here. So similarly, we can put here, we have put here a equal to what you call 1 and b equal to 4. We can as well remove from here the value of b, right? And try to include that value here. Okay, still now we should be able to get the same result. Yes, so we should be able to still write in the same. So please remember that initialization comes here or outside the for loop. Incrementation comes here or inside the for loop. Okay, initialization comes here or before the for loop. Incrementation or iteration comes here or within the body of the for loop, within the body of the for loop. See what I have done here. I have put here two initializations with a comma operator, two incrementations with a whatever iterations, rather one incrementation and one decrementation with a comma operator. Okay, so this is how we can use the comma operator to put more than one initialization statements as well as iteration statements. You can have more than two also. Okay, it can be 1 or 2 or 3 or 4 or 5 initialization as well as the what you call iteration statements. Okay, more than what you call iteration statements. So once we have finished with this, let us see the other type of statement which we have here. Okay, so same thing, I think we might have written there. Yes, this is what we have written here. Both the initialization as well as the what you call iteration statements are put within the for loop. You can still put one of them outside and one of them inside. You'll get the same value. So just because we have put a ln here, each one of this is coming in the next line. If you remove the ln here, then a and b printed will be on the same line. And if you remove this ln also, all the things will come in a single line itself. Okay, so that may not be all that good, but removing this ln might be a better solution. Okay. So in C and C++, comma is an operator that can be used in any valid expression. However, in Java, the comma is a separator. Okay. Further to that, so the other variation which we have already studied is this, that is any other condition you can use which gives us a Boolean value. Not done will also give a Boolean value. So as soon as we interrupt it, if we what you call if the interrupted is false, then done will be true, and true once this becomes true, and not true will become false, and hence we come out. Okay, not true condition is not satisfied if done becomes true. If done becomes true, not done will not be satisfied, hence we come out of the loop. Okay, so if we try to interrupt, then we'll break it and come out. If it's not, program is not interrupted, then it keeps on executing. Okay, that is what it will do over here. So this is a different variation where we are putting any other, value which will give us a Boolean value. Okay, this condition should be a Boolean value. Also, we need not have, what you call anything within this for loop. Okay, no initialization, no condition, no termination, but that will lead to a infinite loop. Okay, that will lead to a infinite loop, which might not be advisable. Okay. Then we come to the for each loop, right? Now let us see what a for each loop is using the different set of slides. Okay, so here we have the for each loop with a different style where we write here type itr var collection. So what it does is from the collection it will pick up each of the value. For each of the value it will execute the statement block. So type specifies the type and itr var specifies the name of the iteration variable. So this collection is basically a array. The collection is basically a array. From the array, it picks up the value. Okay, it's basically a one-dimensional array. Okay, it picks up from that value, from the collection value. And for each of those values, it executes the statement block. Okay, so ITR specifies the name of the iteration variable that will receive the element from the collection. From here, it will receive and it will get assigned with this. And one at a time from beginning to end, the statement block is executed. So with each iteration of the loop, the next element in the collection is retrieved and stored in ITR var. The loop repeats itself all the elements until all the elements in the collection have been exhausted, obtained, or might be exhausted. Till all the elements in the collection are exhausted, it will keep on assigning with the ITR var. And using that, it will go into the statement block and execute it. So because the iteration variable receives values from the collection, type must be same as compatible with the elements stored in the collection. So whatever is the type here, if this is int, within the collection also we should have integer variables. If it is double, within the collection we should have the double values. If it is char, we should have within the collection the character values. So the following fragment uses a traditional for loop to compute the sum of the values. So you can see here, we have taken the array for nums with values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we are putting sum equal to 0. Then we are putting for int x colon numbers. This is the format. It should be colon number. So this is an array. From this array, it picks up a value 1 first, goes inside, prints the value of x, then, what you call sums that value with the sum. Sum is initially 0, 0 plus. So this is a combined, assignment and addition operator, right? So it will just do sum is equal to sum plus x. So 0 plus 1 will be assigned to the sum. Then again it goes for picking up the next value for x. It will pick up 2, print the 2 over here, and then go for 1 plus 2 will become 3. Then again it picks up 3. Then it will the sum will become 1 plus 2 plus 3. That will be 6 and so on till the time it picks up the value 10. So when it picks up the value 10, then it prints 10 and then makes the value of sum equal to the sum of all the numbers 1 plus 2 plus 3 plus. So this statement is just adding each one to the previous sum, each number to the previous sum in between. That means this is in the last iteration, this is getting added with the sum of all those things previously, written. So thus we will get here this, system.out.println summation, plus sum. Might be if you try to put it inside this or here and put summation now is, then what we will get, we can try to check that also. Okay, let us first take this and try to check that. I don't know whether I'll get this at all. Okay, I'll get it. I think int is not coming. Okay. So let me go to the JDoodle and try to put it there and execute. Oh, again, we have one more or one less. Yes, one more might be. Yes. So it is, what you call value is 1, 2, 3, 4, and all that. And then the summation 55. I'll change the statement, which is something like this. From this place, I will remove it and put it here. Except that summation now, I'll put here now. Okay. So each time, it might print the value. So you can see that, first it will be 1, second it will be 1 plus 2, third it will be 1 plus 2 plus 3, 6, then 1 plus 2 plus 3 plus 4, that will be 10, 1 plus 2 plus 3 plus 4 plus 5 will be 15, and so on till it gives a value 55. So you can, rearrange the way in which you want in a better way, to look in a better way, so that, we get the result.